Bench testing a 1963 Cadillac non-fog light option headlight switch, serial number RKHS06122025, offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, dome courtesy light operation. Test number 4, dash lights set low to high. Test number 5, circuit breaker test. Test number 6, switch terminals insulated from ground. During a run-up test, going to be using a fully charged battery. Right now reporting about 12.78 volts. And under boost we're at now reporting 13.34 volts. Also during the run-up test, going to monitor the rheostat temperature in Fahrenheit and degrees. Right now we're at ambient around 86 degrees. Test number 1, tail and parking light operation. First position, we have our tail and parking lights. We're going to set the rheostat for the dash lights to low and off. Again, first position, tail and parking lights. First position, we have our tail, parking, and dash lights set to low and off. Test number 2, tail and headlight operation. First position, we have our tail and parking. Second position, front parking lights come off and your headlights are on. And back to first position, headlights are off, parking lights come back on and off. Test number 3, dome courtesy light operation. We have the ability to rotate the pull rod and ground the stem. And we have an indication of the dome courtesy light coming on. We turn that off. That option is also available in first position. Rotate the rheostat, indication dome light. Second position, dome light. Back to first position, rotate the rheostat switch, dome light, and off. And that feature is available with the headlights and parking lights are off by rotating the rheostat pull rod stem. Test number 4, dash lights set low to high. First position, we're going to set our dash lights to low. Let's go right to off first. That's the off position. And then right to the low, the very end of the coil. And we see we have a little bit increase of Fahrenheit at the rheostat core temperature. Back to mid-range. (93 degrees) to bright, full bright, back to mid-range, second position, headlight position, we're at mid-range on the dash lights, go to the low position, to the off position, to low or dim, mid-range. We'll let that sit there for a second. We see we have 98 degrees Fahrenheit reporting. That probe is actually connected to the outside of the ceramic insulation. The core temperature would be much higher. The probe is actually on the outside of the ceramic. Back to first position. Let's set the dash lights to bright. Full bright. Mid-range. Low. Off, mid-range, and off. Test number 5, circuit breaker test. Delco Remy headlight switches had an onboard circuit breaker. This is a bimetallic contact arm that if there's an overheating in the circuit, the bimetallic arm will expand and break the connection between the battery and the switch. This design will protect the wiring in the vehicle and also the switch. So we're going to put this in first position. We're going to demonstrate that there's an overheating or a short. We're just going to expand the arm. And we see the connection between the battery and the switch is disconnected, and from the switch to the vehicle wiring is also disconnected. This protects the wiring and the switch. Features also available in headlight position. You can demonstrate simulation of the expansion of the arm, breaking the connection between the battery, the switch, and the vehicle wiring, protecting the system. Back to first position, expansion of the bimetallic arm, the circuit breaker, disconnected from the battery, and off. Test number 6, switch terminals insulated from ground. Using a standard 12-volt test light and demonstrate that the switch terminals are insulated from ground. We're going to test the chassis of the switch, and we see we have continuity back to the battery at the switch chassis. We're going to probe each one of the switch terminals and demonstrate that the switch is insulated from ground. This is our courtesy dome light ground tap. We see we have no continuity back to the battery. First terminal, this is our dash light feed, no continuity back to the battery. This is the battery terminal, no continuity back to the battery. Headlight, no continuity back to the battery. Tail light, no continuity back to the battery. Parking light, no continuity back to the battery. And of course, this is our battery circuit breaker. We see we have no continuity back to the battery. The only continuity we have back to the battery is at the chassis of the switch. This demonstrates that the switch terminals are insulated from ground.